Wow. Hello, everyone. The old friend, new friends, welcome back. It's our second lesson for our short-term course related to everything about word problem in SASMO. When I designed this course, I found it super useful. And most of the challenge, even for our long-term course students, when the first time to learn it, they will find super hard. So it's a great chance for you, no matter review what you learn or the first time you get touch into this topic. I will teach you the most useful and classical method to solve all of them. Okay, waiting for some of you join. Not sure everyone already joined. 13 people. 13 people is still in the live room. Cool. Thanks for your support. Today is Saturday. You should have your break time, but thanks for coming here to support our Think Academy, to support you kids learning. Okay, if you are here, you can send something in the chat box. Oh, one of my fans come here. Thanks for your support. We still have 3 minutes, so no worry about that. After our lesson, you can enjoy happy dinner time. But before that, that is a math dinner. Learn something interesting. Few minutes. Hi, welcome, dear parents, dear friends, dear kids. Happy to see you this Saturday evening. So excited. We almost get started. Last 1 minute. Last 1 minute. Yeah, I saw some of you gave me the thumbs up. If anyone know me, already watch one of my live course, you can send something in the chat box. If I saw that, I will reply. Okay? 1 minute. Just last 1 minute. Maybe last 30 seconds. Okay, hold on. We're almost get started. Waiting for more people join. Once again, if you are new here, today our topic is about word problems in the SASMO competition. And word problem, no matter in the SASMO competition, in all kind of competition, even in the school syllabus, is a very important part. Okay, now exactly we are on the 5:30. So it's a great time for us to get started now. Okay, in case you don't know what we learned today we have 4 parts can covered here. We got 4 word problem. They're really important. I just take all the questions from easy to difficult. And first part, we just simply starting from a very easy type of question, excess and shortage. For those one parents are here, let me briefly introduce why I put excess and shortage on the first section. Because in the primary school, when kids trying to learn this kind of word problems, what we really want kids to learn is not how to solve the question, but there is a very important thinking method, thinking strategy called analyzing the difference. Find the difference between the different things. So that's it will be the key point. Not algebra, but difference. Already? Our first question coming here. Okay, now in our excess shortage problem, you will always found a Mr. Friendly or Mrs. Friendly. Why? Because there's always someone who have a very warm heart, want to share something to you. Like in this case, some students are dividing some pencils. I don't know who, maybe teacher Cherry is giving you these pencils. And in this situation, so in the first scenario, some of the students, each one can get 5 pencils. There will be 9 pencils left over. Second scenario, if everyone get 8 pencils, there's a shortage of 8 pencils. How many students and how many pencils are there? Okay, so in this case, if you are the students, would you want to take the scenario 1 or scenario 2? Well, personally, I will take scenario 2 because I can get 3 more. Yes, when we say I can get 3 more, we already do the difference analyzing. But that is the first question, so I want to everything be clear for you. In the excess shortage problems, this was easy. You know, we are trying to distribute pencils to students. So there are 2 important concepts we need to know before everything gets started. What is the items? Items in this case is the pencils. Items means the things or something or even the people we're trying to give out, distribute, allocate it, arranged. That is item. How about groups? Group is the lucky guy, lucky place, lucky group. The group can receive group items together. Who receive, who get, who gather all the items. In this case, they are students. Just want to remind you, sometimes the people could be the items, sometimes the people could be the groups. It depends. Okay, and that once we know we are trying to distribute pencils to students, what should we do on the next step? Scenario 1, think about. When we say excess, shortage, are we talking about excess of items or excess of groups? Of course, excess, shortage of the items. First scenario, it directly tell you 9 pencils left over. So of course, that is excess scenario. Excess of how many? Excess of 9. Scenario 2, everyone get 8 pencils, so that there will be a shortage of 18. Very good. It directly tell us is short of 18. Once we know that, here we go, everyone. If it's your first time to learn the excess or shortage problem, or if you haven't learned the excess shortage problem in the Olympic math level, please write down these things when you do such questions. Can avoid a lot of casual mistake, I promise. And first step, we found out what is small difference. Small difference simply means each, okay? Each of the students, each of the group can get how many more or how many less compare the 2 scenarios. So we can easily find out, compare with our first scenario, our second scenario can get 3 more. 8 minus 5, we got 3. Secondly, what is our big difference? When we're talking about big difference, you need to think about our Mr. Friendly or Mrs. Friendly. If he or she want to prepare something for you, how many more he need to prepare? Not everyone gets 3 more. Everyone gets 3 more. 3 more pencils. Is that okay? I just keep the same amount of pencils? Definitely not. You need to prepare more, right? So in this case, what's the big difference? Wow, that's the tricky part. why we call excess shortage problem. Think about, in the second scenario, if I want to give more pencils to their students, firstly, I will do what? I will distribute all the pencils we already have. There are 9 pencils left over, so definitely we will use them. So 9. Is that enough? No, you still need to buy 18 more pencils if you really want to give everyone 8 pencils. So what's the meaning of that? You need to plus 18. And then you get how many? You get 27. 27 means what? In total, you need to prepare 27 more. Okay, how could we get number of groups? How could we get number of groups? In this case, I will wait you for 5 seconds. If you can use your clever brain to remember or think about this question clearly, do it. 5, 4, 3, 2, 1. Okay, maybe it's quick, little bit quick. Here is a short formula. I didn't write it down because I think it's not a formula, it's a thinking strategy. That is really tricky part why we can use the difference analysis to get our final answer. If everyone gets 3 more, in total, I need to prepare 27 more pencils, which means there are how many students are there? We will use the big difference divided by small difference, which is how many? 9. Okay, let me write down. We will use the big difference divided by small difference. Divided by small difference. Very good. Okay, so that is how we get number of groups. Okay, everyone, take notes if you are not sure about that. Similarly, once we got the number of groups, how can we get the number of items? The number of items will be so clear. Now we know there are 9 students. You can take whatever the scenario 1 or scenario 2. I take scenario 1, everyone get 5. There's still 9 excess. So what's the final answer? 54. So there will be 54 items here. Okay, that is the first question. And apart from this question, I prepare a little summary for you. How could we deal with these questions? Step 1, 2, 3. But I told you before the step 1, 2, 3, there's one more step. Identify the items and groups. This part is so important, especially in some difficult high-level questions. Great, I got gaming. Yeah, gaming, you're really good. This time you also send your answer for me. Okay, and this part I can give you over 30 seconds to take notes. And may I ask you, am I a little bit laggy? I'm not sure because I think someone said I'm a little laggy and it's a little bit blur. Can you see it clearly? Okay. And in the meantime, you can use there's 30 seconds to take a screenshot or take notes here. Just step 1, 2, 3. By the way, when we're talking about excess shortage questions, excess shortage don't always means there's 2 scenarios. It has to be excess shortage. We also have the excess, shortage, excess, shortage, and excess for balance. Shortage for balance. Okay? What's the difference? The difference is, can you really equally distribute everything? Okay? Cool. Okay, now time's up. Let's move on to the next question. If you already handle what we learned in this part, the next question will be super easy for you. Here we go. Some students having a dinner party, if there are 8 students sit at each table, there will be 6 people left without seat. Oh, so sad. If there are 10 students seated at each table, there will be what? There will be 1 unoccupied table. How many students are there in total? So in this case, I'm trying to identify the first question for you, which is, what is our items and what is our groups? Is that the students' items or the table is the item? If you want to answer this question, just think about in the real world scenario. Are we trying to arrange students into each table, or we are arranging tables into each students? Oh my god. We are not the monopoly of the table master, right? You don't need to own so many tables. Of course, we're trying to arrange students into each table so that the number of students is the item. The number of table is group. So once we know that in the scenario 1 is excess or shortage. Excess of what? Excess of the item, shortage of item. So when we say without it doesn't mean shortage. Instead of that, the students is excess. We have more students. It's excess of how many students? Excess of 6 students. Scenario 2, there will be one unoccupied table. What's the meaning of that? Unoccupied. Let me briefly introduce this word for you. Unoccupied means this table is no one used. They're left over with one more table. But listen carefully. Why is it left over with one more table? Does that mean there's excess of what? Sorry. Why I keep repeating the items and the groups? That is simply because when we're talking about excess or shortage, it only depends on the items, not groups. So in this case, this unoccupied table, if the students could sit in, it can highlight how many people sit here. It can provide 10 seats. However, do we really have there's 10 seats? No, we don't have. Why? No, do we really have these 10 students? No, it's the shortage of 10 students. We don't have these 10 students, okay? It's short of 10. Okay, let me write down students. Always short of the 10 students. Excess of 6, shortage of 10. And the rest of the question is so easy. Compare with our first scenario and second scenario, there will be how many more students sit in each table? 2 more, so 10 minus 8, we got 2. Secondly, what is the big difference here? Compare with the first and second scenario. In the second scenario, if we really want the 10 students set in each table and is equally distributed, we need how many people? We need how many students? Firstly, we need the 6 students. All the people sit here. But it's not enough. We still need 10 more people, but we don't have it. That is 10. Plus take 10, we got 16. Lastly, a quick check. Remember what is the formula? When we got big difference, small difference, how can we get the number of groups? 16 divided by 2, we got 8. And once again, always I want to remind you, let me clarify it again. What is the item? The item is the students. The groups is the table. So that in this case, when we got 8 refers to 8 students or 8 table, 8 table. How many students are there? We can either take the first scenario or the second scenario. First scenario, 8 times 8 and then plus 6. We got how many students are there? 70. Yes, exactly. It's SGN, you are right, and you move very, very fast. Congratulations to you. Okay, that is a typical question, slightly hard. Do you feel the difference? Because in this case, we cannot directly so easy to find out whether it's excess or shortage. That is a tricky part. So that's the reason at first I already told you why the items and groups distinguish them are so important. Okay? Now one more question. Mrs. Dai give a group of students some candy. If each student receive 4 candies, she will have 12 candies left. If each student receives 6 candies, Miss Dai will have given out all her candies. How many students are there? How many candies does Mrs. Dai have at first? Okay, you can observe this question by yourself. Do you think this question is easier or harder than our previous one? You can think about it. Easier or harder? Actually, this one's easier. Why? I told you excess and shortage problem. Yeah, easy. It's not only one type of question. It's a much more easier one. When we read the second scenario, Mrs. Dai have given out all her candy. What's the meaning of that? Excess or shortage? Neither no, because it's just equally distribute. It just equally distribute all her candies. Great. Once we know that, oh, by the way, I think I skipped one more step, because in this case, when you see the Miss Dai, she is our Mrs. Dai, she is our Miss Friendly today. The item is the number of candies. The groups is students. First scenario is the excess of 12 what? 12 candies. Second scenario is what? It's no, it's not excess or shortage. Shortage is just a balance. So if you have to see, you can write excess or short of 0. Okay, I think it's strange, but if you really want to copy what we did before, you can use the number 0 to represent this scenario. Okay, so why we use the 0, it can make you the next step a little bit easier. Everyone get how many more? 6 minus 4, we got 2 more. And then the big difference, that's the difference. I see excess 12 excess of 0, so you need 12 more, just 12 more. Number of group, 12 divided by 2, you got 6. And then number of items, take whatever you want. I will take the second scenario. Why? It's balanced. So 6 times 6 perfectly equally distribute 36. Okay? Always remember what is the items, what is our groups. Okay, everyone, easy, right? That is our first section about what is our excess shortage problems. Always remember the really important section is our difference analysis. Checking small difference, big difference, find the number of groups, especially step 3. When you do more questions, sometimes when you're in a competition, you will one time totally forgot what are you looking for. So my personal recommendation is we are learning math, we are not learning questions. So remember, every time in the excess shortage problem, compare the two different scenarios. If each one get how many more, in total I need to get how many more, so that what? How many people, how many groups are there? That'll be much more clear for you. Okay, and for the calendar problems, I love this type of question. You know why? For the calendar problems, is a lot of kids really struggling with that. But it's really related to our everyday's life. For example, every day we live in a day. You can depend on whether it's the Wednesday, Tuesday, the week of that, or you can determine your birthday is on which day. Once you know today is which day. Is that very amazing? Okay, so later when we introduce the calendar problems for you, if you want, you can have a try to determine maybe how about 2023. At that moment, your birthday is on which day? Okay, that is my today's tricky question, interesting question for you. Now, let's move on. What is the calendar problem? A typical calendar problem will look like this one. I know exactly a date. Here is 5th June of a particular year, don't know which year. It's a Friday. Of course, it cannot tell you which year. Why? Some of my students, they're really clever. You just use the phone to check the calendar. Oh my god, you don't need to do so. We are learning math, it's not searching. AI can do that, not you. So 5th June of a particular year is Friday. I know exactly a day is which day. Now we are looking for June 30th. Now let me introduce for you. In the calendar problem, basically there will be two thinking methods. One thinking method is finding the total days. Another is finding the how many days later. There are two thinking methods. Today I will only cover one thinking method. How many days later? If you found it's a little bit hard, we can discuss it in the group, okay? About days later and total days, what's the difference? But today I will only introduce this type of question, because this type of method, because I found it super useful. Now let's check it. What day is June 30th on that year? June 30th and June 5th. What's the tricky part? They are exactly in the same month. When they are in the same month, I want to check with you how many days later, okay? How many days later will we get into June 30th? So when you're checking days later, which day you didn't include? Today. Today. You didn't include today. If you can't understand this one, let me briefly introduce a question for you. Do you know today is which day? Today is Saturday. One day later, will you cover today? One say tomorrow. Tomorrow is one day later. Will you count today? No, right? You just, today is February 15th. Tomorrow is February 16th. You just use 16 minus 15 is okay. You don't need to plus 1 because we're looking for how many days later. Okay, sorry, Ping is not plus 1. Why not? We don't need to plus 1 because we are looking for days later, not total days. If you are looking for total days, you need to plus 1 because you include June 5th that day. We don't need to include today. If you forgot that, always remember. Oh, Xiaomi, yeah. Sorry, Xiaomi. And then we can know. Always remember one day later, you don't need to count today. Here we go. We just happily, easily use the 30 minus 5. We got how many? 25. Why we need to learn the calendar problem? Because all the calendar problem, basically, they are the cyclic problem. There will be one certain cycle for 1 week, which is 7 days. Now, use the 25 divided by 7. We got 3, remainder 4. Okay, the most important part coming here. What's the meaning of remainder 4? If you want to know that, you need to know what's the meaning of remainder 1. You know, today is which day? Today is June 5th, which is a Friday. So, when checking, oh, no. I'm just checking today is Friday, is okay. Don't care about it's the June 5th. Okay, today is the Friday. And remainder 1 simply means 1 day later. Well, 1 day later, there will be Monday. 2 days later, that will be Tuesday. And 3 days later, that will be Wednesday. Oh, sorry, what I'm doing? Oh my god, I moved too fast. How could it be Friday and then Monday? We're Saturday and Sunday. Okay, so sorry for that. Oh my god, we are in Saturday and I just make Saturday and Sunday disappear. Oh my god. I don't want to do that. Okay, everyone don't make the same casual mistake as me. Because everyone, we don't want the Saturday and Sunday disappear, right? So Friday, after that, Sunday, and then Monday, and then Tuesday. Great. So you got remainder 3, remainder 4. Remainder 4 means what? Just means 4 days later. 4 days later. Here we go. I just keep some round. Because if you are not sure about that, you can take 1 week, 2 week, or 3 week as example. You will understand what I'm talking about here. 7 days as a cycle. Once after a cycle, it will start repeat again. So I just take one cycle is okay. Remainder 4 means 4 days later. That answer here is Tuesday. Great. Okay, secondly, what day is July 10th on that year? It is a little bit level up. Why? It comes across the months. Across months, no worry. You just checking June and July. There's 2 months, it's okay. So similarly for June, how many days? We already covered. How many days later? Always remember, we are checking days later, not total days. How many days later in June? There will be 25. For July, do you need to cover July 10th this day? Yes, we do. Yes, we do. Why? Because when we say days later, of course you need to include the end day. So don't worry, there are just 10 days here. So in total, how many days later? 35 days. When you use the 35 divided by 7, you will find, wow, it equals to 5. 5 means what? No remainder. No remainder is which day? No remainder is just today, Friday. So answer here, luckily, we got that should be Friday. Got it, everyone? Yeah, so easy. That is the classical calendar problem. In our Think Academy, I think P2 students should already learn it. And in P3, we review it again. When you get into P4, it's still the same. We will not learn anything new. That's all. So that's the reason I told you SASMO is not a so difficult competition. A lot of the content we already learned before. Now, before we move on to the next question, I prepare a little tricky part. Have you watched this table before? We call this one as the table method. Why we use the table method? Because every time when we're talking about calendars, the cycle is just in your mind. How can we make this cyclic much more clear for you, combined with our figure? That is where table method could be helpful for you. Now, table method give you 2 important information. Firstly, for any of the months, the number of months is between 28 to 31, right? When you consider about the leap year, some of the time, the February maybe have 28 or 29. And normally one month have the big months or small months related to 30 or 31. So the number of months is between 28 to 31, at least until here. So if we assume a month is 31 days, and listing it like this, you will find an interesting thing. There must be 3 days of a week have 5 times, appear 5 times. There must be 4 days of a week appear in 4 times. What's the meaning of that? That connected with the cycle of 1 week. Normally we are starting Monday, Tuesday until Sunday. But actually a cyclic as a cyclic can starting from any day. For example, I can starting from Saturday. And then Sunday, Monday, is that okay? Yes, we can. Of course we can do that. Wednesday, and then Thursday, finally Friday. So here you go. You will find, personally, I really love this type of things. Oh, if I am you, I will pick the Friday on the first one. So you will find a month that full of the Friday, Saturday, and Sunday. Both the Friday, Saturday, and Sunday have appeared 5 times. I love that so much. Everyone like the Friday night and Saturday, Sunday for break time. So that will be a perfect time for you. But in this case, I just want to remind you, 1 week as a cycle. Any day could be the starting day of 1 month. Okay? And 1 day's date is according a range between 28 to 31. Now, if you know that, this basic knowledge, let's check this question. In a given month, there are more Tuesday than Wednesday, more Mondays than Sunday. What day of the week is the third of this month? So this question, I think, explains some of you's misunderstanding or question for me. Even I didn't see your question, I know some of the clever boy or clever girls maybe ask me this question. Dear Terrence, why we need table method? When can we use it? Here you are. When you found the question describing about the number relationship between how many Tuesday, Wednesday, how many days of a week, you should consider about our table method. Let's do it. And do we know whether this day is the 28, 29, 30, or 31? We don't know, but we can assume that. Firstly, is that possible this week? Only this month only have 28 days? Definitely not. If that is 28, every day will be the same. There's no difference. Secondly, if this day is only 29 days, is that okay? Still not possible. Why? Because you will find apart from this row, this column, all the other column, they are just 4 days. How it could be maybe fit with the Tuesday more than Wednesday, but how about Monday more than Sunday? Not right. How about we consider about the 2 days or 3 days? Yeah, that is possible. So at least this month should have 30 days or 31 days. Is that possible we got 31 days? We can assume that. So we only have, there are more Tuesday than Wednesday, more Monday than Sunday. So Monday, Tuesday, they are so close. If I listing like here, Monday, Tuesday, Wednesday, look here, if that is 31 days in a month, they are the same. It's not possible. How about we change the order? If not put Wednesday here, I put like the Monday, Tuesday here, so that Wednesday will be here, smaller, but you will find Sunday will be here. So the tricky part is, it also cannot be 31 days for a month. It has to be 30 days. So only 30 days. Once you know that, you also know how could we arrange the 2 days. Just Monday, Tuesday, followed by Wednesday, Thursday, Friday, Saturday, and Sunday. All the days on the right side, there's 1 to 5 column. They are just appear 4 times. And every number on the left 2 column appear 2 times. Okay, I love this question so much. You know why? Because I think it's related to the method. If you don't know this method, you are also struggling. What's the meaning of that? However, once you can use this method, use this table method, everything is so clear, right? No one will be struggling with 1, 2, 3, 4 count. It's 1, 2, 3, 4. This 1, 2, 3, 4, 5. It's so obvious. Great. And for the calendar problem, we almost finished. There will be last one question, I guess. So this one is quite similar as the first one, but similarly, it's across a month, and in the meantime, you will find May 15th is a Friday. What is the April 1st? April 1st is not after May 15th. It's before. So in this case, our question is not how many days later. It's how many days before. How many days before? I will ask you the same question. When we're checking how many days before, should we include today? Okay, so how about yesterday? Oh, yesterday is an interesting day. It's February 13th, February 14th, Valentine's Day, right? Valentine's Day yesterday. That is how many days before? 2 days before? No, 1 day before. When we say yesterday, that is, yesterday is 1 day before. So we will not cover today similarly. So in this case, we will checking it. We only covered 2 months, May and April. For the May, when we didn't cover today, that will be 15 minus 1. Before that, there will be 14 days in May. And in April is a big month or small month? We can calculate it. We can quickly calculate. June, you know, for when we determine big or small months, it depends on one big, one small, one big, one small. But there will be 2 months. They are very, very special. That is the July and August. July and August, both of them are big months, have 31 days. Okay, it's not related to this question, but I think it's a really interesting knowledge point. If some of you don't know that, July and August, why they are both a big month? There is one of the story talking about why. I'm not sure whether it's true, but I think it's interesting if you remember that. There is one of the king whose name is August, and he is born in August, and he just cannot accept his month is a small month, so he directly changed the August into a big month. Have you heard this story before? Okay, I'm not sure whether it's true or not, just maybe some rumor, but I think it's a great chance for you to remember July and August, they are both the big months. So we'll come back to this question. April is a big month or small month? It's a big month, so April will have the 31 days. In the 31 days, I know some of you also have a little question. Teacher Charis wonders 31 days. Do we need to cover the day itself, April 1st? Of course, yes. When you count, yesterday is 1 day later, you don't need to cover today. You don't need to cover the yesterday. If you didn't cover yesterday, which means 0 day before, we're in a special cycle. So strange. So first, all in all, how many days before? There will be how many days before it across the whole April? That is 45 before. It will be 45 before. Oh yes, I show you in the Dr. Egg, 45 days before. And 145 divided by 7, you will find that there will be how many days? That will be 6, remainder 3. Similarly, when you see remainder 3, what's the meaning of that? Remainder 3, based on our previous knowledge, that means 3 days before. 3 days before. And 3 days before, will we cover today? Will we cover just today? No, we will not cover today. So Friday, go back to 1 day later, remainder 1 is Thursday. We go one more, that will be remainder 2, which is Wednesday. We go remainder 3, that is which day? Is the Tuesday. I saw some of you send me the message. You think the final answer here it will be the Wednesday, Friday, Tuesday, Thursday. Oh, am I got something wrong in this part? Let me quickly check for you. Quickly check. Yes, I guess your answer is right. In this case, it should be have the actually Wednesday on that day. So let me quickly check for you. Okay, and so in this case, oh yeah, I noticed what's the problem. In this case, the problem is whether the April is the big day or small day. I just told you a story, and I think the 3rd April is the big month. Oh, when checking the big or small, I checking the May, not the April. That is my problem. So April only have the 30 days. So in this case, that will be 44 days. What's the difference. So when you got 44 days, 44 divided by 7, and then you will get, that is remainder with 2. So remainder 2 is 2 days before, so we don't need to cover the Tuesday. That is Wednesday. Yeah, exactly. Okay, no problem. That is 2 days before. Great. And until now, we just covered everything about our calendar problems. And let's have a quick break time. And during the break time, you can play this little game. Fine, there will be 9 difference here. Okay, see you later. I think it will cover maybe 3 minutes. 3 minutes later, we will come back to the later section. There will be 2 more word problems. See you later. Okay, I will be still here, but just take a quick break time. And if you have any question for the first part, feel free to ask me about that. Did you find there's 9 difference? Last 1 minute, and we will get started into our next section, our next part, for our the most difficult section. The next 2 parts, we will learn the fraction word problems and I think it will be struggling with some of you page problem. Those 2 questions are not a P4 level. It's actually the P3 level question. However, some of the question could be very, very hard. One of the reasons for the fraction word problem is that before the fraction word problems, you need to know how could we calculate the fractions. How could we calculate the fractions? Okay, so I will not teach you how to calculate fraction in today's lesson because our today's focus will be word problems. We will checking what is the basic meaning of fraction word problems, how we solve this type of question, what is the most important thinking method. Okay, so for the calculation of fraction, at least you need to handle, firstly, what is a fraction? Secondly, you need to know how could we do the fraction addition and subtraction. You also need to know how could we deal with the fraction multiplication and division. That is a little bit hard. For example, how could we deal with that 8 times 2 over 3? 8 divided by 2 over 3. How to do that? That is slightly hard. And if you can't, there is another way. You can use the unit, that method. That is quite common in your school syllabus. Is if some of you need to test the PSLE, that is the most common method. So today, our focus point will be what is the most important thinking method in the fraction word problems. Are you ready? Let's check the first one. Lily borrows a book in a holiday. She read 1/3 of the book on first day and 24 pages on the second day. Half of the book left. How many pages half of the book was left. How many pages are there in this book? So we are looking for how many pages of the book. We only know one information related to the number of pages, which is 24. How can we solve this question? In a fraction word problem, if you are not sure about that, drawing a model will help you understand everything. So usually when we see the fraction, why we need fraction? Fraction describe a relationship between part and the whole. Part and the whole. So what will be the whole? Whole will be 1. So I draw a model that is whole. Represented by what? The total number of pages. So firstly, I read 1/3 on the first day. On the first day. And then, what happened? I read 24 pages on the second day. And then, once we finish this day 1, day 2, there will be half of the book left over here. Sorry, I clicked too quick. Yeah, here you are. There will be half of the book was left. So which means this part is half of that. How many pages are there? In this case, the most important part is we need to find the relationship between part and the whole. Once you found this relationship, you can find the answer. In this case, the whole is the whole pages. That is what we're looking for. We know exactly one number, one value, which is the part of the pages. That is 24 on the day 2. So the day 2, 24, represent how many of the total. It take part, give me a fraction. How can we deal with that? Now, we will use the total 1 minus first day 1/3 minus the last day 1/2. Okay, so how can we deal with that? In this case, I told you today is not related to the calculation part. So if you really want to do that, it involves maybe you need to change the different number of we will change every fraction into the same number. Okay, now let's check it. 1 minus 1/4. Oh, okay, some of you already gave me the answer so quick. So 1 minus 1/3 equals to 2/3. 2/3 minus 1/3, how can we deal with that? We will change every number into the 6th part, not split into 3 parts or 2 parts. We will make them as the same, the 6th part. And then this part will consist of 4/6 minus 3/6. So we got 1/6. What's the meaning of that? 24 refers to 1/6. That is the part-whole relationship. How can we find the total? The total is 24 times 6 equals to 144 pages. Okay, so for this question, you can take notes here. Let me give you 1 minute. 1 minute, you can take notes here, and then we will move on. In this case here, why I need you to take notes? Drawing the model can help you much more clear about what the question looking for. Okay, yeah, I got a lot of thumbs up. I guess that is you finished. Okay, next question. Tom had some Lego blocks. He lost 4 pieces at home and then gave 1/4 of the remainder to Gary. After that, he lost another 30 pieces and gave 1/3 of the new remainder to Fiona. After that, another 2 pieces were lost. He gave half of the new remainder to his brother. In the end, Tom had 19 Lego blocks left. How many Lego blocks did Tom have originally? Oh my god, everyone, the first time when I checked this question, I found, oh, Tom, why you always lose the pieces? Here 4, here lose 3, here lose 3, here lose 2, here lose 4. In the end, you only have 19 Lego left here. And when we solve this question, can I draw a model like the previous one? I firstly draw a hole and split out this one 1/4, this 1/3. The answer is no. Why? Because each of the part-whole relationship when we use the fraction, 1/4, this new denominator represent the 4 parts is the whole part, is the total. However, the next one, the 1/3, this 3 as the denominator doesn't mean the total same. It's the remainders 1/3. Is we already take off something and we left with something. So in this type of question, how can we deal with that? There is another thinking method. We call it as the working backwards. Working backwards. We will start from the ends to the beginning. So here we go. We will firstly mark down all the information here. Firstly, loss 4, minus 4, yes. And then I gave 4. So everyone, here's the tricky part. Always remember, once we write down the steps, we are trying to represent the remaining one. How many left over here? Got it? So that's the reason I gave 1/4, so I'm not writing down times 1/4. Instead of that, I times 3/4. 3/4. Because that is the part we left here. And then the next step, I lost 3 more. I gave 1/3 more, so I actually remainder 2 times 2/3. Keep going, and then when we lost another 2, and then gave half, I remainder 2. So what can we do? Finally, I got how many? Finally, I got 19. Now is your great chance to working backwards. Now I have 19. So firstly, what should I do? I divide it by 2. When we do working backwards, every sign will reversed. Every signs will reversed. Every number will be kept here. But in this case, everyone, later you will see I write down a slightly different. I told you the number will be the same, but the sign will change. However, if you are familiar with the fraction calculation, you will know divided by 2 simply means times 2, right? Simply means times 2. So when you times 2, you got how many? You got 38. Next part, minus 2, so I plus 2. Luckily, I got 40. When I times 2/3, so I should divide it by 2/3, which means what? Times 3/2. That's the difference. Okay? And then when we times 2/3, we will get 60. Next part, when we minus 3, so we plus 3, and then we got 63. Next part, when we times 3/4, we should divide by 3/4. In the meantime, it equals to times 4/3. So that equals to 4/3 times 63 is 21. So final answer here is 84. But lastly, there will be one more step, which is plus 4 more. Our answer will be 88 pages. Congratulations, some of you already got it correctly. Big thumbs up to you. Very good, very good. Okay, so proud of you. So you can see, when can we use the working backwards? When you notice the denominator always see the part-whole relationship, the meaning of the whole parts always change from the remainder to new remainder to new remainder to new remainder. You should consider about working backwards. Okay? Every time the part-whole relationship is based on a different whole number. How about for this one? Avery is reading a science book. She spent 1 week reading 21 pages more than 4/15 of the whole book, and there will be still 8/15 of the whole book left. How many pages are there in this science book in total? Remember, I showed you two types of question. In this case, 4/15 and 8/15, the denominator, does that based on the same whole part? Yes. Why? It told you the whole book. Both of them depends on the whole book. So I can write down the big model. I draw a model to show that is the total part. And then one first day, that is how many? 4/15 of the whole book, but there are still 21 more than that. What happened in that? 8/15 of the book was left over. Once I show you this model, I think it's quite clear. I still need to find the part-whole relationship. What is the 21 refers to? 1 minus 4/15 minus 8/15 equals to 3/15, which exactly 1/5. 1/5 refers to 21. So the total part is how many? Total part is how many? 21 divided by 1/5, which is 21 times 5. We got 105 pages. Answer, 105 pages. Okay, everyone, this question I move a little bit fast because I think the basic idea, once you understand, find the part-whole relationship, everything will be so clear. If you found it's a little bit struggle, I understand why. It's not related to the word problem part, it's related to the calculation part. You are not so familiar with how could we calculate the fraction division and fraction multiplication. So don't worry about that. Even you don't know that, in your school syllabus, you will learn how to use a unit to transfer between them. Okay, fraction is hard, I understand that. Last question, maybe the hardest question in our today's lesson, one of the hardest. Some students are traveling home on a school bus. 1/4 of the students got off bus on the first stop. 2 more than 3/8 of the students got off the bus on the second stop. There are still 14 students left. How many students were there at first? Firstly, it's still the same. I need to determine, is that the 1/4 or 3/8 refers to the same whole part or the different whole? The same whole. They are both refers to the total number of students. So here we go. Let's try to double check with that. That is whole. How could we reference to 1 less than 1/4? So here we go. Firstly is the 1/4. I use the orange color to show you. That is 1/4. However, exactly is not 1/4. There will be 1 less than 1/4. There will be 3 more than 3/8. I use the blue color to show you where is the 3/8. But there are still how many more? There are 2 more than that. In the end, there are 14 students left over. If we want to solve this question, actually we better find out what is the left part reference to. However, when you do this question, you will find the tricky part. What is the tricky part? The tricky part is which one should I relate to the rest of parts? The rest of parts. The rest of part. One way is you thinking, oh, I know, dear Cherries, so it's just the 16 refers to the rest of them, right? But if you think so, you will ignore something. That is this one number. Why this one number is so special? Because that is one line that exactly it's not exist here, but we assume we want to get 1/4, so I draw a model like this. But in the end, you should do what? this 1 over 4 shouldn't be included in this part. So actually you left the number of the students you left over should be 15 minus 1 and then plus 2, which is 15. And 15 refers to what? The whole part apart from the 1 over 4 and apart from 3 over 8, it equals to, let me check, exactly 3 over 8. Okay, and then when 15 refers to 3 over 8, how could we find the total? 15 times 8 over 3. So that is how many? 5 times 8. We got 40 students were there at first. Okay, for this question, I know it's slightly different compared with what we learned before, because when you calculate the part and whole relationship, the number of part and whole is not so easy for you to check. Why is not so easy for you to check it? Because there will be more or less. Actually, there's one easy way to understand it. How many of you already learned the sum multiple difference, this type of question? If you already learned the sum multiple difference, that type of question, you will remember there is one of the important conclusion we can get from that. That is, if we have more than, we will plus. If we have less than, we will minus. That is the basic conclusion. Okay, so if you haven't covered this type of question, take this one as example. Try to do more practice for that. Okay, so exactly, I think I should write down one more thing here. It should be 15 divided by 8 over 3. And then equals to that. Oh, divided by 3 over 8. Okay? Until now, we already finished our first 3 parts. Now, let's welcome to our last part for today's lesson. Page problems. Page problems. Do you like reading books? Okay? If you read books, you will notice a very interesting things. Here we go. We will have some knowledge preparation before we move on. For the range of book from 1 to 9, if I say the pages are page 1, page 2, page 3, how many digits are there from 1 to 9? There will be 9 digits. And then for the range of from 1 to 99, there are how many digits? Is that the 99 digits? No. Why? Because you will find from 10 to 99, every number have 2 digits. So exactly it's 2 times 90 plus the first 9 digits. It's 189. How about 1 to 999? It's even go further. Why? Because you will find between the number 100 to 999, each of the number will have 3 digits. How many of there are there? 2,889 digits. So once you know this basic conclusion, you will be much more easier in our page problem. Okay, everyone? I think this one is I prepared for you. It's really, really important. If you can, okay, I click too quick. Take a quick screenshot for this page. That is so important. The conclusion part, if you understand everything inside this learn discover, the later question will be super easy for you. And the SASMO competition page problem will be easier for you. Okay? Ready? So in this case, we can decide whether a number of the book's page is between 1 digit, 2 digits, or 3 digits. We can go back to find out it. Later, we will check this little figure again and again. From a very easy question, there are 215 pages in a book. How many digits are used in the page number from 1 to 215? For this question, we can still classify every number starting from the range. So the first range from where to how many to how many? It was from 1 to 9. Why from 1 to 9? Because everything you hear, you just only use one digit. So digits will be 1 times 9 equals to 9. The second range, okay, I will change another way to write it down. I will not write down 1 to 9. I will write down from 10 to 99. Why checking from 10 to 99? Because in this case, every digit you will have 2 digits, 2 times. But 2 times how many? It depends on the number of pages. Is that 90 pages here, 100 papers here, 90 pages here? Exactly, there are only how many pages? 80 pages here. Oh, let me check how many pages. 80 pages. 80 pages here, from 10 to 99. And then, oh, sorry, it should be, no, sorry, 90 pages. Because we exclude the first 10 pages, the first 10, oh, that it should be first 10 pages. Oh, 10 pages, no, 9 pages, okay, sorry. And then, when you're checking the number of the digits, that is how many? The number of digits, you will use each of the page. There will be 2 more. And then 2 times 90, you will get 180. Remember, in the previous one, I show you this one. From 1 to 9, right, all right. So in this case, that's the difference. I didn't starting from the 1 to 99. I starting from the 10 to 99. Why starting from 10 to 99? Because in this case, we are looking for the digits range by range. It will be much more easier for you to do the rest of 2 questions. Okay, and when we determine that is the odd number with 1 digit, odd number with 2 digits, and then what should we go on? We should go on with the number with 3 digits. There is one question for you. For a book, have 215 pages. The digits is in which range? Range 1, range 2, or range 3? Of course, it belongs to the range 3. And the reason why I split there's 3 parts for you is, one, we know 215 pages. Firstly, how many pages are there in that range from the 100 and to, I don't know, 200 pages? I know the 215 pages should minus the 90 pages we already have, minus the 9 pages I already have. So in this case, you will find the range is what we're looking for. Okay, and for the 215 to minus 90 minus 9, you can get how many? In this case, when you keep solving this question, 115 minus, that will be 1, let me check how many, 100 and oh, sorry everyone. In this case, you don't need to be so hard. You don't need to be so hard, because we already know there will be 201 pages, 215 pages. 215 pages, 215 pages, you just need to simply use the 115 minus 100 plus 1 more. It's okay. You don't need to so hard to go back looking on from the range to pages. And then when you use the 215 minus 100, you got 115 plus 1. You got how many? 116 pages. For 116 pages, can I see there will be 116 digits? Definitely not. there is a very special part because all the numbers between 100 to 215, they all include 3 digits. So 116, you also need to times 3. You got 348 pages. So our answer is 348 pages. Is that right? Is that right? Definitely not. Always remember what we're looking for. We should looking for the digit. The digits are used in the page number from 1 to 215. So you need to do the last step. It's 1 plus 180 plus 348. You need to plus the sum of all the digits from all the pages use only one numbers, all the pages use the 2 digits, and all the pages use 3 digits. Your final answer will be 537 digits. Okay? So in this type of question, the really tricky part is the next time when you do it, maybe you can write down like me, range, pages, digits. That is how we classify each of them. In this type of question, the page number of a novel must be printed with 149 digits. How many pages are there in this book? This question you will find what's the tricky part. It's just the reverse. From we know the pages, we want to know the digits, to we know the digits, we want to know the pages. We know the digits when we want to know the pages. Similarly, we will still do the similar thing as we did before. Firstly, for all the digits, from the 1 to 9, you use the 9 pages, there will be 9 digits. From the number from the 10 to 99, you will also use the 90 pages, but there will be 90 times 2 equals to 180 pages. That is what we did before. But you will find 180 digits is already bigger than 149. What's the meaning of that? Remember the figure I showed you before? If you are familiar with this figure, you will know 189 if is smaller than that, which means it must be in the range of this section. Okay? Once we know it is a 2 digits number, it must be between the 10 to 99. We can, starting from the 149, to go back to find the pages of that. How could we find the pages of that? Here we go. It involves a very interesting part. Can I simply use the 149 to divide by 2? Because everything here related to the 2 digits? No. Why? Because 149 it also includes the first 9 digits. So our first step should we use 149 to minus 9. That is all the numbers we left with only 2 digits. When we know everyone have the 2 digits, how many pages? Go back. Divided by 2. Divided by 2. Oh, divided by 2. We got the number of pages. So, in this case, it equals to 140. And 140 divided by 2, because each page will use 2 digits. And then we got 70 as the final answer. Okay, but 70, is that the final answer? Is that the final answer? So, how many pages are there? 70 pages are there. Is that right? Yes or no? Everyone? Quickly answer me. 3, 2, 1. Definitely not. Why I didn't write down the answer in the last step? Because you should remember, I just told you the pages between this range is 70. How many pages exactly are there? You should plus the first 9 pages. That is 79. 79 pages here. Okay, how many pages are there in the book? 79 pages. See, what's the difference? We know the pages, find the digits, or we know the number of digits to find the number of pages. The next two questions will get a little bit level up because we are not only looking for how many digits are there, we are looking for the certain digits of that. For example, number 1. How many times the digit 1 appear in a normal which page number are printed with in total of 1998 digits? What is our starting point? If you want to know the digit 1 appears how many times, what should you know? You should know the number of pages. Know how many digits is not enough, because if you don't know the pages, you are not sure whether it's the 2 digits number or 3 digits, 1 digits or 2 digits or 3 digits number. Luckily, in this case, I highly recommend you just look at what we did before. If this one is between 2 digits and 3 digits, at most is how many? 2,889. And this number have how many digits? Only 1,998, which means it must be a 3 digits number. Once we know it's a 3 digits number, I think we can follow what we did before. Firstly, range 1 from 1 to 9, there will be 9 pages with 9 digits. 998 digits. You can find out in the last range, it must be 100 to some number. 1,998. You say to minus 189. You will find there how many digits are there. The calculation. Okay, I want to remind you, some of the time it's not you don't know how to do it. It's some of the time you will make a lot of casual mistake when you do calculation. Exactly. So I'm the same. Sometimes I do a lot of calculation. I also made a casual mistake. So how about we just then you will take away 1, take away 1,809. 1,603 is the final answer. No. 603 is not the final answer, because you will find previously there will be another range of that. So if I write it down, that should be, we used 1,999 minus, okay, everyone, when you do the question, maybe if you want to show the teacher, you will look like this one. 1,998 minus 9 minus 180. And then divided by 3. And then once you divide by 3, you got pages. Is not enough. It's not enough. Because our final target is not just looking for the how many pages are there in this range. We are looking for how many pages in total. In previously, you got how many numbers are there? You got 99 numbers are there. You got 99 pages are there. You got 99 pages are there in total. So finally, in this case, if you find your final answer, that will equals to how many? Let me check. 702. It will get 702 pages. Once you got 702 pages, is that the end? No. That's why this question is slightly hard. You also need to double check how many 3 digit 1 are there. Digit 1. So for the 1st digit between 1 to 700 and from the page 1 to page 702, how many times does the 1 appear in the 1st digit? Let's listing for you what happened when 1 could happen. It was like 1, 11, 12, 21, 31, and keep going until the last one should be 701. So how many are there? It means how many times will one happen in 1st digit? Okay, tens. There are how many? 70 plus 1 more, because 701 there is a special one. So exactly there will be, change another color. 71 number, 1 on the 1st digit. How many times will happen to the 10th digit? Similarly, how could we see the 1 appear in the 10th digit? It's like the 11, 10, 11, 12, 13, 15, 15, 16, 17, 18, 19. So from the from 10 to 19, this range is so special. What is the next special one? 110, 111, 112, 113, 114 until 119. So each time when the 1 appears in the 10th digit place, it will appear with 10 numbers. How many groups of 10 numbers can we have? 7 groups. So exactly there will be 70 on the 10th digit. How many are there on the 100th digit? Oh, this one is so easy, because once it happened in the 100th digit, there must be starting 100 something something. How many number between 100 to 199? Exactly, just 100 number. So finally, once you got all the numbers here, you can finally find out our final answer. That should be 71 plus 70 plus 100. That equals to 200. 200. It should equals to how many? It equals to 241. Quite big number. 241. 441 times appear for number 1. Oh, congratulations, we finished that. I told you that may be the slightly hard for the page problem. Last one. There are 46 threes in the page number of a comic book. How many pages are there in this book? Similarly, when we know a certain number of the digits appear, we go back to find the pages that even go further based on our previous question. In this case, I just made this model for you. Now, let's consider about all the numbers could appear with 3 in the range of 1 to 9. That consists of how many pages? 9 pages. The digit 3 appeared in the 1st digit is how many times? The number 3 in the 1st digit is 3. Is 10 digits? No. 100 digits is 0. But everyone, when you do this one, you will find a strange part. Sorry, I read wrongly. It should be only 1. I just decide this range 1 to 9 as 0, but when I decide it's 1 to 9, there's only one 3 appeared. So if I keep going, I think we will write down too long. So how could we simplify our steps? Bravely. If you are familiar with the number, you will know we don't need to set a range from 1 to 9. The range from 1 to 9 cannot solve too many things. We will set a quite big range. How about we set a range between 1 and 100. So you will find there are 100 pages. How many 3 could appear on the 1st digit? When it appears on 1st digit, it will look like 3, 13, and 23, 33, until what? Until 93. So how many 3 are there on the 1st digit? 10 times. Similarly, okay, I write down the example for you in case some of you don't know how to do it, like the 13, 23, and the 33, 43, and go on until 93. There will be 10 on the 1st digit. How many 10th digits are there? For example, number 3 on the 10th digit. On the 10th digit place, I'd better write down 10th digit place. 10th digit place. Because we are talking about place value. Example, and that will be 31 until 39. Of course, there are just 10 of them. Hundreds digits place? No, that is just 0. Just 0. And when we checking the range between 1 and 100, the sum of all the number have digits 3 is how many? That's 20. Wow, it's close. And then how about we check the next round between 100 and 200? That also include 100 pages in this part. And once digit can appear, remember we are starting with 100. For example, it's quite similar as this one. 113, 123, 133, until what? Until 193. So how many 3 appeared on the ones digit place? Also 10. Also 10 numbers. How about for the tens digit place? Exactly the same. There's nothing difference. Just we add one more 1 before that. 131 to 139. So that will be in total tens number. Hundreds digits place, sadly, is still 0. But until now, the sum of there will also be 20. But see, everyone, from 1 to 100 is 20, from 120 is 20. Now we already have how many? We already have 43s. 43s. We're only left with 6. What can we do with that? Just thinking about from the 201, what is our next number with the digit 3? We will firstly consider about ones digit place. So the first one, it will be, I change a different color, green one, 203. The next one, 213. Next one, 223. Next one, is that 233? No, why not? Because you will found. I always checking just one, we just focus on the ones digit could be possible, but how about for the tens digit when we get 230? So here we go, we will got 230, 231, 232. Until 232, we just appeared how many times? 6 more times. So our final answer for this question will be 232. Yeah, I know everyone, it's a little bit hard, but these 4 questions are step by step. If you found the last one you can't understand, try to go back to check which question you already start misunderstand, okay? You need to do it step by step. You cannot mix one of that. Here's a quick summary for our page problems. Always remember the numbers in a range. It should be n plus star. Don't forget to plus 1. But in today's lesson, we didn't cover about this type of question. Everything is the same. I want you to remember is be careful where to start, where to end, especially this figure. Okay? Range, numbers, number of digits, that is so important. Here's the little summary. By the way, that is everything for our today's lesson. Hope you enjoy it, and don't forget our interesting question. Okay, it needs you some time to review everything, but just until now, enjoy your happy weekend. Bye bye everyone, see you next Monday evening, the same time. Bye bye, see you next time. Bye bye.